There's another integration technique that students should know. It's called trigonometric substitution. It's when the integrand has terms like square root of a squared minus x squared, square root of a squared plus x squared, or square root of x squared minus a squared. We do what's called an inverse substitution. So now we assign directly the value of x. So here we would take x equals a sine theta. So then we have the square root of a squared times 1 minus sine squared theta, which we can convert. Here we would take x equals a tangent theta, and here we would take x equals a secant theta. These type of integrations can get very complicated, but let's look at a simple one. So as an example, let's integrate from 0 to 1, a definite integral of square root of 1 minus x squared dx. So first you should look at the integral. So as x goes from 0 to 1, the square root will stay positive, and then this integral should then be a positive value. So if we want to integrate this, we use a trigonometric substitution. It falls under the category of the square root of a squared minus x squared with a equals 1. So the right inverse substitution here would let x equal sine theta. So let's see how that works. So we let x equals sine theta. Then we end up with dx, right, is cosine theta d theta. So that means we're going to substitute in for dx the function cosine theta d theta. So this integral then, the integral from 0 to 1 of root 1 minus x squared dx becomes the integral 1 minus x squared would be the integral from 1 minus sine squared theta. Dx then would be cosine theta d theta. And because this is a definite integral, we should figure out what the limits are. So when x is 0, theta can be set to 0. So we can integrate from 0. And then x increases from 0 to 1. Then this, in order to get sine theta to go from 0 to 1, theta would go then from 0 to pi over 2. So we would change the limits like that. So continuing, 1 minus sine squared theta is cosine squared theta from Pythagorean theorem. The square root of cosine squared theta is cosine theta, and then we would get a cosine squared theta d theta. So this becomes the integral from 0 to pi over 2 cosine squared theta d theta. Okay. This one we've done already. I can move it up here. So we use the reduction formula. So it becomes 1/2 the integral from 0 to pi over 2. And then we have a 1 plus cosine 2 theta d theta using the reduction formula for cosine squared theta. This is straightforward. So 1/2. Then we have the integral of 1 is theta, plus the integral of cosine 2 theta is sine 2 theta, but the derivative of sine 2 theta is 2 times cosine 2 theta, so we need to divide by 2, and that goes from 0 to pi over 2. We can look at the second term here at pi over 2. That would become cosine of pi. Sine of pi is 0. At 0, that would become sine of 0. Sine of 0 is 0. So the second term doesn't contribute. The first term only contributes at pi over 2, not at 0. So this becomes 1/2 of pi over 2, or pi over 4. Okay. So this is one of the simplest examples I can think of. this integration can become very difficult. So you can always resort to software. So this is called a trigonometric substitution. It's an inverse substitution. The first time we've done that, we assign x a value instead of the other way that we've been doing it is to find a u and a du. So here we assign x directly a value. And then we did the simple integral from 0 to 1, square root of 1 minus x squared dx. And I showed you how we can do that. I'm Jeff Chasnoff. Thanks for watching, and I'll see you in the next video.